Chapter 8, Section 3, Solving Right Triangles. Pause, come back and check your work. So we are warming up with a little bit of which theorem? Yes, the Pythagorean theorem. C equals square root of 89, B 11, and find the sine of B. Wow, that's the next, oh, that was from yesterday, so 0.6. Okay, so we have, using our what formula here? That's right, our distance. And that is what you should have found. So the objective is to use trigonometric ratios to find angle measures in right triangles and to solve real world problems. Here's an interesting question. Identify angles from trigonometric ratios. So you're asked to use the trigonometric ratio cosine A equals 24 over 25 to determine which angle of the given triangle here is angle A. So we know that it must be angle 1 or angle 2. These are the two non-right angles in this triangle. And so we can imagine or find the ratio for cosine of each of these angles, can't we? So cosine, again, cosine, think of SOHCAHTOA, right? Cosine is adjacent over hypotenuse, right? So for angle 1, we would have adjacent is 1.4 over hypotenuse is 5, right? Okay, and if we find an equivalent fraction with a denominator of 25, we blow this thing up, we end up with 7/25. Cosine of angle 2, again, would be adjacent over hypotenuse, so 4.8 over 5. And when we blow that fraction up and find an equivalent fraction, we have 24 over 25. So, since the cosine of angle 2 equals the cosine of angle A, angle 2 is angle A. Interesting, huh? So use a trigonometric ratio to determine which angle of this triangle is angle A. Pause the video, come back and check. So we have to recall that sine is so, right? Opposite over hypotenuse. Opposite over hypotenuse for angle 1, opposite over hypotenuse for angle 2. So which of those ratios equals 8/17? And we simply substitute and find angle 1 and angle 2. And what is 8/17? Since 8/17 is 0.47, angle 2 is angle A. They did not show you that 8 over 17 has a decimal equivalent of 0.47, so you had to find that, didn't you? And again, you may use your calculator. Remember that important hint that you should not round until the very end when you're using your trigonometric ratios, okay? Use the given trigonometric ratio to determine which angle of the triangle here is angle A, and now we're talking tangents. Tangent A. Pause and come back. Once again, tangent, we got to remember that relationship. TOA, opposite over adjacent, right? So for angle 1, we have opposite is 27 over adjacent 14.4. And for angle 2, we have opposite is 14.4 over adjacent is 27, right? And so which of these is equal to tangent A? And you can see angle 1 equals tangent A. So angle 1 and angle A are the same angle. So in the last lesson, we learned that sine of a 30-degree angle is half, 0.5. Conversely, if you know that the sine of an acute angle is 0.5, you can now conclude that the angle measures 30 degrees. That is written as the inverse sine, 0.5, is 30 degrees. So if you know the sine, cosine, or tangent of an acute angle measure, you can use the inverse trigonometric functions to find the measure of the angle. So if sine of angle A is x, then the inverse sine of x will give you the measure of angle A. The same is true for cosine and tangent. If you know the sine, cosine, or tangent, we can use it to find the actual angle measure. Just take the inverse function. So we can do this with our calculator, and you definitely want to do it with your calculator. The other way to do it would be with a table, which you can find at the back of your book. But you're going to be using your calculator, so let's find the angle measures for the given trigonometric ratios here. To use the inverse function, on our TI-30 X2S calculators, and on most calculators, you find the sine, cosine, and tangent buttons, right? And to access the inverse function, you simply press second function, and then the trigonometric function that you want. So in other words, for the first one here, we would press second function cosine. That gives us the inverse cosine. As you can see on your TI-30, it looks just like this, right? And then you have an open parentheses and you plug in 0.87. And because that's all we have, you don't even have to close the parentheses. Just simply press enter. And when you do, you end up with the nearest degree, or not the nearest degree, you end up with a more precise answer than to the nearest degree. If we're going to round this angle to the nearest whole degree, then 29.5 would round to approximately 30 degrees. Okay? And we just simply do this with each. So again, you press second function sine, and you get the inverse sine for a ratio of 0.85, and press enter. And when you do, you end up with a decimal answer, which can be rounded to the nearest degree, in this case, 58 degrees. And again, inverse function tangent for the ratio 0.71 gives us this decimal equivalent, and so we round that to 35 degrees. Okay, kind of fun, finding angle measures using your inverse trigonometric function. So using given measures to find the unknown angle measures or side lengths of a triangle is known as solving a triangle. To solve a right triangle, you need to know two side lengths, or one side length and an acute angle measure. So we are asked here to find the unknown measures, round the lengths to the nearest hundredth, and angle measures to the nearest degree. Find the unknown measures. So we are looking for all unknown measures, side length ST, and the two unknown angles, angle T and angle R. Okay, we're going to find all of them. So because we're working with a right triangle, we are able to find ST using your Pythagorean theorem. So we are missing a leg, right? So we can say that the hypotenuse squared equals the two sides squared, and substitute your known values and solve for ST, and you have approximately 2.74. Okay, now we're finding the angle R. Now to find angle R, we know all sides of this triangle at this point, so we could use any of the trigonometric ratios, right? So let's see how we're doing it here. In our key, to find angle R, the inverse cosine of, cosine again is adjacent over hypotenuse, right? Adjacent over hypotenuse gives us a 29-degree angle. Go ahead and find T using whichever ratio you like and come back and check. So here in the key, they didn't use a ratio, of course, since we know we have a 29-degree angle and a 90-degree, we simply can use our addition sum, triangles, angles add up to 180 to find the one missing angle, which is 61 degrees. if you used a inverse function to find angle, no worries, let's just move on to example 4. Solve a right triangle in the coordinate plane. The coordinates of the vertices of triangle PQR are P, negative 3, 3, Q, 2, 3, and R, negative 3, negative 4. Find the side lengths to the nearest hundredth and the angle measures to the nearest degree. So you must begin by plotting the triangle in the coordinate plane, and I think I've left that open for you to see in your notes. So we are able to quickly determine the length of PR, which is 7, and the length of PQ, which is 5. So if we're going to find the length of RQ, how might you do that? Yes, your Pythagorean theorem. We have a right triangle, so we're missing the hypotenuse. So they're using the distance formula. Same thing, isn't it, as our Pythagorean theorem, and they found that RQ equals approximately 8.6. Again, to the nearest hundredth for the side lengths and to the nearest degree for the angles. So here we have 8.60 for length RQ. Now that we have all side lengths, we can find angle R and angle Q using any of the ratios that you would like to use, right? So again, angle P is 90 degrees because PQ and PR are perpendicular segments. PR is opposite angle Q, and PQ is adjacent to angle Q. So if we're going to find angle Q, we could use opposite over adjacent, right? We have those values. And so opposite over adjacent is which trigonometric ratio? That's right, it's tangent, right? So we can use the inverse tangent of that ratio, 7 over 5, and find the nearest degree, 54 degrees. So if angle Q is 54 and angle P is our 90 degree, we simply subtract 54 from 90 to get angle R, and therefore we have measure 36 degrees. We have found everything. We have solved this right triangle. This is a really important travel application because when you drive in your life, you're going to find yourself in different terrains, some of them going very steeply up and some going down. And you're going to see signs on the highway that warn you that a section of the road has a certain percent grade. And so what does that mean? I think there are a lot of people driving around out there who don't really know what that means. But if they're truck drivers, believe me, they've been educated because it affects their ability to brake. And in many cases, trucks have gone out of control because they weren't paying close attention to the grade and then their brakes went out. So super important. This is why highways post these signs. So if a highway sign warns that a section of the road ahead has a 7% grade, to the nearest degree, what angle does the road make with a horizontal line? So we know that 7% written as a fraction is 7 over, that's right, 100, right? So this means that a 7% grade would be equivalent to rising or falling 7 feet for every 100 horizontal feet. So there's your slope, right? Rise of 7 over 100 or drop of 7 over 100 feet. So here is an image of that you have in your notes, right? And so if we want to find the angle that the road is making with a horizontal line, which would be just a flat place, right? Then we could take the opposite over adjacent ratio here, which is tangent, right? The inverse tangent of that slope, 7 over 100, and we see, when we do, we get a 4-degree angle. That is the angle that the road is making with a horizontal line. Seems rather small to you, but depending on the distance, the length of that road can have a big impact on truck drivers and their trucks, okay? Go ahead and pause, try the lesson quiz, and come back and check your work. We should have these unknown measures and degrees, and there you go. And once again, take your time to make sure you have tried this in the coordinate plane. This is not a race. Be thorough and find the side lengths and the angle measures. You should have found these. There you go. Have a good day.